that for now. Okay. Alright, so we mainly have three topics. The first one is cloud native, just a brief definition of what it is. Then Kubernetes, of course, this is kind of the focus of today's presentation, so I'll spend some quite time talking about this. SQL Server and Linux. I need to explain you guys the SQL Server journey to Linux that will make sense once we apply those concepts while using it on a different platform, is Linux-based platform as Kubernetes. Okay, and finally some demos. Of course, we'll have some fun. Hopefully, you guys will like this presentation. Okay, so let's move to the first topic, cloud native. This is kind of a buzzword that you will see and hear everywhere, right? But defining cloud native is quite simple. It's an approach to build and run applications that exploit the advantages of cloud computing delivery model. Now the question will be, how do we build these cloud native applications? Well, we have these four cloud native architecture principles. So the first one is DevOps. Obviously, it is a collaboration between software developers and IT operations with the goal of delivering high quality software that solve customer challenges. Then we have continuous delivery. This is the ability to get changes of all types, including new features, configuration changes, bug fixes, into production or into the hands of the users in a safely, quickly, and sustainable way. Then we have microservices. This is an architectural approach to developing an application as a collection of small services. Each service will implement its own business capabilities, will run its own processes, and communicate via HTTP, APIs, or messaging. Finally, we have containers. So containers offers both its efficiency and speed compared with standard virtual machines, because the virtualization occurs at operating system level. CNCF guidelines recommend that cloud native applications should embrace 6 important pillars. The first one is the cloud and its underlying service model. Second is modern design principles that we have to apply through microservices, then containerization and container orchestration. Cloud-based backend services such as databases and message brokers, and finally automation, which is a big thing here, including infrastructure as a code and any code deployment, of course. Alright, so let's go back in time for a moment and have a look at the evolution of software development through the years. First, we have the traditional deployment era. Early on, organizations ran applications on physical servers. There was no way to define resource boundaries for applications in a physical server, and these caused resource allocation issues. For example, if we have multiple applications running on a physical server, there can be instances where one application will take up most of the resources, and as a result, other applications will underperform. Then we have virtualized deployment era. As a solution to the problem caused by the physical hardware, virtualization was introduced. It allowed us to run multiple VMs in a single physical server CPU. The problem was that each one of those VMs will run a full copy of its operating system, all its components, on top of a virtualized hardware. So that takes us to container deployment era. Containers are similar to VMs, but they have relaxed isolation properties to share the operating system among different applications. Therefore, containers are considered lightweight. Similar to a VM, a container has its own file system. It has its share of CPU, memory, process space, and more. As they are decoupled from the underlying infrastructure, they are portable across clouds and OS distributions, which is a really big deal. So in summary, containers are a really good way to bundle and run applications, but at the same time, we face a new challenge. Imagine a fully containerized production environment. You will need to manage containers that runs applications, of course, and ensure that there is no downtime. For example, if a container goes down, another container needs to be started right away. And managing thousands of containers manually doesn't sound like a good idea. Will not be easier if this behavior was handled by a system? Enter Kubernetes. So here you have the actual definition of what is Kubernetes, if you want to read it. In a nutshell, this platform was originally created by Google using Golang, and it was handed over to a CNCF in 2014. Kubernetes provides us with a framework to run distributed systems in a resiliently mode. It also takes care of scaling and failing over your applications, providing you with different deployment patterns and more. Okay, so let's take a look at the basics of Kubernetes. This is a high level summary of the components that makes the core of Kubernetes. Okay, first we have the master. This is kind of the brain. It has multiple moving parts, multiple processes running. It runs in a single node of a cluster, can be multi-node as well, so different options there. It tells others what to do. It is responsible of maintaining the desired state. Okay, then we have nodes. They do the work. They just run the applications. They were called minions in the past, and they are also responsible of reporting back the state to the master. In case there are CPU pressure, something going on, they will be responsible to take that information back to the master for the master to make some decisions based on that information. That's really cool. Then we have pods. Pods, it is, I would say, like it's workspace or a logical place where a container runs. We can have one or more pods running within a node. Then we have services. Services help us to hide multiple pods behind a service, like a service IP address like a DNS or a static IP. This is really important because pods are mortal. If there is something wrong with a pod, Kubernetes is not going to try to resurrect that pod. Kubernetes is going to create a new pod in a different node, for example. So having a service to hide that or have that abstraction of the endpoint for our application is really cool. Then we have deployments. Deployments follow a declarative model where we say, okay, this is what we want. We define our desired state, the number of pods, the number of replicas, using a manifest file that is usually a YAML or a JSON file. Most of the people uses YAML, so that's what you would see as today in the demos. Okay. Alright, speaking about the cloud providers, so Kubernetes has been since release, I would say probably 6 years ago. It's one of the fastest growing open source projects to date. Lucky for us that rapid evolution pushed the most important cloud providers to deliver a fully managed Kubernetes service experience for us. There are many offerings in the market, but in my humble opinion, these are the most important implementations. EKS from Amazon, AKS from Azure, and GKE from Google. And I'm kind of biased here because I work with AKS most of the time, so that's the platform that I will be choosing for today's presentation. So what is our Kubernetes services? Well, it's easy. this, as I said, this is a Microsoft offering of Kubernetes fully managed service in the cloud. It comes with a really nice feature around the Azure portal of the Azure CLI if you want to use command line, where it's just a matter to change configurations to scale your cluster or maybe trigger an update without really having to worry about all the tedious infrastructure management stuff. Okay, so fully managed Kubernetes in the cloud with automated patches, upgrades, integrated monitoring, fast end-to-end development experience. With VS Code, GitHub Actions, Jenkins, etc. Okay. All right. So this information about the cloud providers of Kubernetes sounds really good. But what about local development? What if your organization is looking to start something simple and then scale up to a different architecture? Or whether to look at Kubernetes solution that allows you to deploy and manage edge or IoT or ARM type applications. So we have this, I would say, it's difficult for me to explain this, but these are implementations of Kubernetes that you can run in your own machine. So we have different here, as you see, we have Minikube, we have Docker, we have Coin, but let me tell you this, based on my experience, MicroK8s is so far one of the best, or probably the best. Just to give you an idea what MicroK8s is, it's a lightweight and simple implementation of Kubernetes, and actually is the smallest one and one of the fastest in Kubernetes implementations that you can use to run your Kubernetes environment on your computer or somewhere else. It was shipped, developed, and supported by Canonical. So kudos to the guys on Canonical for doing this for free. Thank you so much. You can use IoT, Edge, CI/CD. So just to be clear, this is a local implementation, but it's a production grade implementation of Kubernetes. So it depends on how do you want to do it or how do you want to scale it. You can use it for very interesting things. Okay. All right. So let's talk about SQL Server and Linux. Right? We have the background of what is Kubernetes, cloud native, and everything else. So let's move on to SQL Server now. All right. So Microsoft loves Linux. That was kind of a shocking thing that was said by the Microsoft CEO back in 2015, and well, things has been said rapidly evolving in the Microsoft ecosystem, focusing on developing and I would say offering more solutions that embrace Linux at such a point that right now this is information taken from the Microsoft Azure website, that it claims and it says that more than 50% of VM cores runs Linux on Azure. So wow, that's kind of impressive. And so that adoption back in 2015 led to something really interesting on March of 2016. It was when Scott, who is the executive vice president of Microsoft Azure, he announced SQL Server and Linux. that was kind of a big deal, and more for people like me who are multi-platform data professional with experience in Linux and other platforms. So at that time, Windows was pretty much the ecosystem of SQL Server. And then they embraced Linux. And to be honest with you guys, I think they made the right decision here, because they were standing on the shoulders of a giant here, because the first option to embrace Linux, SQL Server on Linux, excuse me, was Ubuntu. Ubuntu was there, has been in the market for more than 16 years, so that was a good choice. But there was more. So the adoption of Linux opened the door for Docker and Kubernetes as well. And then the evolution led to supporting different Linux operating systems as Red Hat and SUSE. So kind of exciting there. And speaking about the SQL Server containers, excuse me, or Docker, we have to talk about the SQL Server container image. This image is available for us in Docker Hub. You can take a look at the link here and you will get the complete list. But pretty much we can find two versions of SQL Server. SQL Server 2017, starting from Ubuntu 16.04 for all CU versions. CU stands for Community Updates, and it's just a version of a patch. For SQL Server 2019, there was a minor change. Ubuntu 16.04, the version of SQL Server 2019 running on Ubuntu 16.04, it is available for all CU versions, but then the version of Ubuntu 18.04 was available starting from the community update number 3. Okay, so just wanted to give you some insights about the SQL Server container image available for us. Alright, so SQL Server and Kubernetes. This summary that you can see here on my screen is pretty much the steps you need to follow to deploy a SQL Server instance on Kubernetes. It is very straightforward, and I would say that this is kind of a standard deployment for a stateful application. We need to have a persistent boolean claim for our data files, of course. Then we need to create this service to make that pod deployment extraction possible, creating our endpoint for our applications, right? Like a static IP address or maybe a DNS. And then we just simply connect to SQL Server. Alright, so let's have our first demo about local development with micro-k8s and SQL Server. Okay, so here's some kind of guideline that I put in place to get you started with micro-k8s. You have to understand that micro-k8s uses something called multipath, at least for macOS. I'm using macOS, by the way. So I'm using multipath. Multipath is kind of a VM thing that has a VM called primary, and there is another VM for micro-k8s. And why is this so important? As I said, there are a couple of VMs you can see here. So whenever you install micro-k8s, multipath is going to create a micro-k8s VM, and that VM is created by default with 4 gigabytes of memory and 4 gigabytes of disk. Of course, you can use this command to manage that and change that around, but that's something to keep in mind because you will be putting some deployments and scheduling some pods in your local Kubernetes or probably your production Kubernetes using micro-K8s. So that's something to keep in mind. Something else is about the add-ons. That's something I really like about micro-K8s, that you can have control about what you want to have enabled in your Kubernetes cluster. There are some add-ons that are really critical for databases, so I put some information here. Okay, so the next guideline here, it's about having the micro-K8s Kubernetes cluster set in your kubectl context. That's probably silly, but it's so convenient, at least for me, that I can use kubectl to manage my micro-K8s cluster. Without further ado, let's jump into the first SQL Server related demo. Okay, so let's just navigate to this path and let's grab the context of my Kubernetes or kubectl. So I'm pointing to micro-K8s. Remember that I said during the slide the SQL Server on Kubernetes uses a namespace. That's optional, but it's the best practice. Okay, so right now I'm saying, alright, oh sorry, I was doing something wrong. So here, this is what I have to do. I have to set my actual context of micro-K8s to the namespace called case SQL. So that's the name of my namespace here. So all my Kubernetes objects will be created under case SQL. Alright, so everything should be fine now. Alright, great. So here is kind of the steps you have to follow to create a SQL Server deployment in Kubernetes. Here's the secret, that will be the first step. Then the PVC, the persistent polling claim, that you need to make your data persistent. Then the service to make that extraction between pods, deployments, and your endpoints, in this case your applications, and finally your SQL Server deployment. I'm not going to execute this because I already created my namespace and everything else in advance, but I want you to take a look at the YAML files really quick here. So first thing, we have the secret. The secret is fairly easy. It just has a string here for the SA password, and that's it. Okay, let's take a look at my persistent polling claim, and this is quite special. So Kubernetes has different implementations of storage. In this case, it's a type. The type of storage is local. So my PVC data case is gonna use some capacity that is assigned to my micro-K8s VM. Remember, 40 gigabytes. So it's gonna use 6 gigabytes, and so that's okay. All right. So let's take a look at my service. My service is here. Right, so my service is, as I said, an instruction is using node port. So it's saying, okay, the port on my container 1433 is going to be, exposed to my node as 1400. Nothing complex as well. Okay, and finally my deployment. This is the SQL Server deployment. So let me just zoom in a little bit here and go through the deployment. Okay, so this is a stateful app in Kubernetes. The name of my deployment is this. I am putting some labels here for my application. The name of my application and container is going to be SQL case. Here's my strategy for the container. It's going to recreate a container whenever something happens with the container. The termination, grace period for upgrades or outages or anything else, it is 5 seconds. So that means that it's going to wait 5 seconds until shutting down the container. And this security context for the file system group 1000, it is just a way to say, okay, group 1000 will be able to write and read into the SQL Server volume. In this case, SQL Server Linux runs under the MS SQL service account. So that's pretty much it. Here's my version of SQL Server. Take a note here because that will be relevant in next demos. I am using CU6 Ubuntu 18.04, so CU6 SQL Server 2019. The container port is 14.00, and here's the environment variables of my container. The first one is the end user license agreement. I'm saying yes, I agree, and then is a password. Remember, I show you the secret I created, so it's grabbing the value or the key, the value from the key as a password and passing that information using the secret to my environment variable. Then the volumes. I'm creating one volume within the container called MSQL to be mapped to this path, and this volume, guess what? It is going to use my persistent volume claim. And here's the best practice. I am limiting the resources of this container. That's a good practice for overall for any deployment in Kubernetes, but this is really important for SQL Server. My memory, this container will be able to use up to 2 gigabytes, and I put that information here. I include that information here. Yeah. So this is a pro tip. As I said, putting quotas to your containers is a really good idea, but we have to be really careful when we're dealing with SQL Server because it has some system requirements for Linux. First is the memory, 2 gigabytes, so I'm okay. Then cores. Microcates is gonna use as much cores available from the host machine, so in this case I'm okay, and this space, disk space should be 6 gigabytes, and I'm covered. So be very careful with that. Make sure you are not over allocating resources, or you are not putting quotas to your pods, because you will be in deep trouble. Okay, so here is pretty much it. Let's take a look at the pods on SQL Server. By the way, if you want to follow along and get the information about the service, the PVC and everything else, you can do it. For time constraints, I can't, so I just want to make sure I show you this. So I have my pod here is running. It had a couple of restarts, but it's been there for the past 5 days. Cool. Alright, if I want to take a look at the logs, I can grab the pod name and just use the kubectl logs and take a look at the log and kind of watch what's going on live if you follow along the log. But I will skip that part because I know it's up and running. I know there is no issues at all, so I'm going to skip that part, and I'm going to do this. I'm going to grab the name of my container, and I'm going to do something interesting here. I'm going to do some forwarding of the actual pod port 1433 to my local machine 1401. Why? Because I want to connect. I want to connect locally. Remember, I said this service the Kubernetes service is used to some kind of abstraction, but here I don't need to have like an external IP or public IP because I'm using my local machine, so I can forward the port inside or within the container to my local machine, and I can't connect. Okay, so I'm going to use Azure Data Studio. This is a cross-platform tool that you can use to develop or manage your databases. In case of this demo, I will be using SQL Server, of course, but you can even manage Postgres databases from here. So I have my case is the name of my Kubernetes cluster. That's the name of my connection, excuse me. So I have my databases here, so it's pretty much blank. So let's do a deployment. Let's do a regular deployment of a database really quick. So SQL scripts, planet Earth, database is kind of what I want to run. Let's connect to case. There we go, and run. This is going to create a new database called Planet Earth. We'll have tables, it will insert data, and I think it's done. 2 seconds. It was really quick. So as I said, it's a regular SQL Server, nothing special. So let's refresh information here, and as we can see, I have Planet Earth. I should have countries here. I should have information about continents and everything else. So it's a regular database that we're used to. Okay. Something else, if you want to use something really interesting here, you can leverage Jupyter notebooks. That's kind of big deal for data science, but it will be a great thing if you want to document your environment or maybe create some troubleshooting guide for your team. You can use it. And for example, here I'm connected to case, and I'm just grabbing information about my operating system and kind of details about my instance. Here's my name, my version, my patch level, CU, remember, and it's using Linux, Ubuntu 18.04. Developer edition. Here's the RAM. It's using kind of 1.5 gigabytes and 2 CPUs. Alright, so getting back to your presentation, let's move on to the next topic, the advantages of Kubernetes. The SQL Server deployment in Kubernetes is very straightforward. There are many things to discuss here, but if you take a look at this is kind of why you should use Kubernetes, right? For containerized workloads, but how those benefits can be applied to a stateful application like SQL Server. Achieving high availability for SQL Server and Linux is not easy. I'm not saying it's impossible, but it's a complex process. Patching and upgrading would always require a fair amount of downtime, but luckily for us, Kubernetes has these two things out of the box. Okay, so let's have a demo and explore how we can leverage AKS to be our Kubernetes platform to achieve HA and quick version upgrades of SQL Server. Okay, so getting back to Visual Studio Code, let's have our second demo, and this demo is going to use Azure Kubernetes services. And if you want to follow along, once again, I include some guides here and how to, there you go, how to deploy a SQL Server service, an AKS, actually an AKS using Azure CLI here. Here's all the information. I created 4 nodes, here's 3, but I mean something special. I created a 3-node AKS cluster, but then I add a 4th node that is using Azure container instances. This is kind of a virtual kubelet that would let me use this a special node for burstable things, like ephemeral things that I want to create on the go. Okay, so here is the guide, and if you want to deploy SQL Server on this environment, here's the guide as well. My Kubernetes cluster is called Endurance, and my SQL Server deployment is called Plex. So here's the information if you want to follow along. Let me move forward to this. Connectivity. Remember I mentioned that connectivity is a big deal depending of your implementation of Kubernetes, of course, but here let me show you something interesting. Just let me jump to my Endurance cluster, and then I will set my current context to my namespace called Plex. Okay, I should be good to go. Let me run. Alright, cool. So I'm pointing to Endurance at this point. So let me grab my nodes. Remember I said I have 4 nodes to our SQL Server, and I can show you that I put a couple of labels just to say, okay, these are SQL, and I have one for tools and one for my virtual kubelet. and this will help me to distribute the load. So if I want to deploy SQL Server, I will say, okay, node selector should be equal to SQL Server to put any SQL Server related resource there. Okay, all right, so just let me put this on. All right, cool. So remember, we have services here, and I did something different here. So my SQL Plex doesn't has a public IP, and that's kind of the best practice when we're dealing with data. We don't want people to have access to our data through internet. So I pretty much enclose my environment in this Kubernetes cluster, but how in the world I am going to connect and run queries? As a developer, I need to run queries sometimes to verify things. I should be relying on database migrations to make my deployments, but at least I want to check something. So I created something really special here. This is a Bastion container. You can take a look at what's the name, GitHub. I included some information here. So this container is gonna run in Kubernetes. It's going to create a temporary pod. It's going to run on my node called tools, and it's going to execute a query against my SQL Server. So let's try it. Let's do it, and it should work. So it pretty much returned me the information about my databases living on this cluster, and I can run a series of queries using the same. So I just wanted to give you an idea how you can leverage a different approach to connect to a SQL Server running on Kubernetes, where this is enclosed in a very tight security environment. So there is ways you can do it. We should be deploying in a different way, but if you want to at least verify something, you can leverage this. So this is really cool, and I am doing pretty much the trick I did before. We doing this forwarding of the port and local port to my computer. So if you want to follow along, pretty much the same. Okay, let's move on to a different demo here, number 3. All right, this is more interesting. Okay, just let me, there we go. Okay, this demo is about doing a SQL Server upgrade, and I think we are really short in time, so I won't be able to do it, but pretty much it's easy. What it will take is for you to update the SQL Server image on your SQL Server deployment running in Kubernetes. So remember, I had CU6, and I'm saying, all right, so from now on, please use CU8, and that's it. It's not a big deal. It's really easy, and you can watch the status of your rollout and upgrade, and you can follow the history of what happened, what was the image that was applied, and query your databases after the fact. Okay, so if you want to do it and follow along, you can do it here. Unfortunately, for time constraints, I can't do it, but I will move to something really cool. And last demo, it's short but interesting. So remember, I said achieving HA on Linux is difficult. For SQL Server is kind of complex, but it's not if you're using Kubernetes. So let me just do this really quick here. Right, so what I'm gonna do, I am going to execute this script, and this script is going to simulate a failure with one of the pods, specifically the one where SQL Server is running. Okay, so I won't be giving you much details about what it does, because it's pretty straightforward. It has a lot of detailed information what it's doing. So it's, without further ado, let's execute it. Just let me grab this information real quick here, maximize this, paste it. Yeah, it's not working. There we go. Alright, so let's execute it. Oh, permission problem. Oh, we can solve that really quick. chmon x. Wow, Alright, never expected something like this. Alright, so here we go. It is running, and as you can see, my cluster is endurance. It says I am running this context, and it's done. It took 5 seconds to fail over. That was incredibly fast. Let's take a look at this and get through what was done. So my current pod before the failure was this. Take a look at the name here at the end of it, of this string. So it was running on the pool or the node number 2. Then I deleted the pod, and this was the name of the pod that was deleted. And then pretty much Kubernetes do its thing and created a new pod, and the new pod name is completely different. As you can see, the previous was DLSHV, and this one is M4MWV in the same node. And then SQL Server just was restarted in a different node, and it is up and running. It took less than 5 seconds to do the switch over. How cool is that? If I want to verify it and make sure everything is okay, I can connect on Azure Data Studio, but I know for sure everything is fine. Alright, so getting back to our presentation, let's move forward to the next topic. In this graphic, you can see pretty much what I did during the demos, right? We have this user, an IP, or excuse me, an application pointed to Kubernetes service. This Kubernetes service is pointed to a pod in a node, and this pod is pointed to our persistent public claim where all our data files are hosted. Kubernetes is going to create a new pod in the same node, or probably something goes wrong with the node, it's going to create this pod in a different node, and everything will be safe at persistent volume and persistent. I would say from the persistent perspective, excuse me, everything will be fine because all our data files are hosted in this external decoupled storage. Okay, nice. So SQL Server is not just another Kubernetes deployment. There are more complex and complete solutions like SQL Server Big Data Cluster, which is a scalable deployment that combines SQL Server, Spark, HDFS containers running on Kubernetes, and these running side by side will enable you to read, write, and process big data from Transactive SQL or Spark, allowing you to combine and analyze high-value relational data and with high-volume big data. Okay, and we have Azure Arc as a different solution as well, which allows you to run Azure Data Services on premises, at the edge, and multi-cloud environments using, guess what, Kubernetes again as the platform of choice. Okay, so we have Kubernetes here, and you can implement this service in your own infrastructure. Okay, let's have a recap. So the first topic, SQL Server and Linux. I briefly talk about SQL Server's journey into Linux, Docker, Kubernetes, and everything else, right? Then I talk about a little bit of Kubernetes, which is the platform to go with dealing with containerized workloads, I would say. Then Ubuntu, which is a fundamental player in the cloud native ecosystem, being one of the most popular, most used operating system among modern architectures. And I show you some information, share some information about MicroK8s, the smaller and faster implementation of Kubernetes until today. And then I briefly talk about Azure Kubernetes Services, which is Microsoft fully managed service offering from Microsoft. So I would like to ask you a question now. So what's next? Do you think Kubernetes is ready for the enterprise? More importantly, do you think it's ready for staple apps like SQL Server? I think so. And this is not coming from me. This is from Nigel Porton. You probably know him. He's really great. He addressed this question. Well, it was not long ago, probably a couple of months, when he said that compute was first. That was easy, right? then networking, which was not that easy, but finally storage, which it is always hard. But those three things was already embraced, and I don't know if this is the right word, but certified in the Kubernetes environment. And the key for storage was the creation of the CSI, the Container Storage Interface, which helps to develop and I would say probably in the evolution or the maturity of the service in the Kubernetes platform. Okay. CSI has been available for a year probably, and there are third-party storage vendors that are already using it. We have really good companies behind, like Portworx from Pure Storage and Commvault, doing great things with this. I really recommend you to check that. Okay, so here you have some references, official documentation, books, portals like courses, Microsoft learning paths that you can take a look, some labs, and finally some of the articles that are there that I wrote for Redgate, for SQL Server Central, and that's it. So I have to say thank you. Here's my contact information. Here